Can you recall the different geometrical terms that can be used in these situations? Can you recall the different geometrical terms that can be used in these situations?
Yes, the figures are either congruent or similar. So, two figures are said to be congruent if they have the same shape and size. Similarly, two figures are said to be similar if they have the same shape but not the same size. Why do you think the concept of similarity of figures is used? The idea of similarity of figures is used when it is required to find the heights of inaccessible objects or distance between very far objects. They are applied to such situations where distances cannot be measured using any of the direct methods. Take a look at the geometrical shapes of circles with same radii, squares with same side lengths, and equilateral triangles with same sides. They are all congruent shapes as they are similar to each other. Now, observe the shapes of similar circles, squares, or triangles. Here, each of them does not have the same size, but they all have the same shape. They are not congruent but are similar to each other. Can a circle and a square be similar? No, since they do not have the same shape, they are not similar figures. Thus, we can conclude that all congruent figures or shapes are similar, but all similar figures or shapes need not be congruent. Now, observe two quadrilaterals ABCD and PQRS. Are they similar? These figures appear to be similar, but we cannot be certain about it. There must be some rules to decide whether the two given figures are similar or not. Now, take a look at the photographs of YB but of different sizes. Would you say that all the photographs are similar? Yes, they are. Now, observe the two photographs of the same size, one of which is when YB was 10 years old and the other is his recent photograph. These photographs are of the same size, but certainly they are not of the same shape. You have heard about stamp size, passport size, and postcard size photographs. What does a photographer do when he has to print photographs of different sizes from the same negative? He generally takes a photograph on a small size film, say 35 mm size, and then enlarges it to a bigger size, say 45 mm or 55 mm. Now, observe the line segment in the smaller photograph and its corresponding line segment in the bigger photograph. This means every line segment of the smaller photograph is enlarged in the ratio 35:45, or it can be said that every line segment of the bigger photograph is reduced, that is decreased, in the ratio 45:35. What do you infer from this? Scaling is used here to change the size without changing the shape of the object. The ratio of the corresponding sides is referred to as the scale factor. Scaling multiplies the lengths of all line segments by the same number and produces a similar figure. Further, if we consider the inclination or angles between any pair of corresponding line segments in the two photographs of different sizes, we see that the inclinations or angles are always equal. This is the essence of similarity of two figures, and in particular two polygons, where similarity preserves angles and the ratios of lengths of corresponding line segments. Thus, we can conclude that two polygons of the same number of sides are similar if their corresponding sides are in the same ratio or proportion and their corresponding angles are equal. Is it possible for polygons to be similar to have one of the properties true without having the other true? Let us check this out by taking two quadrilaterals, square and a rectangle. Here, we observe that the quadrilaterals, though the corresponding angles are equal, the ratios of each pair of corresponding sides are not equal. So, the quadrilateral ABCD is not similar to quadrilateral PQRS. Now, Observe the corresponding sides and angles of quadrilaterals, square, and a rhombus. We see that in the quadrilaterals, though the ratios of corresponding sides are equal, the corresponding angles are not equal. So again, the two quadrilaterals ABCD and PQRS are not similar. From this, we can conclude that for quadrilaterals to be similar, they must be both equiangular and proportional, that is, either of the above two conditions, 1 and 2, of similarity of polygons is not sufficient for them to be similar. The two quadrilaterals ABCD and PQRS are similar. Determine the unknown length x in the figure. Let x be the unknown length of the side of the quadrilateral. Here, since the two quadrilaterals are similar, then the corresponding sides must have the same ratio. That is, AB by PQ is equal to BC by QR, which is equal to CD by RS, that is equal to AD by SP. Substituting the known values and simplifying for x, the scale factor is 2, x equal to 3. Thus, to calculate unknown lengths, we need to first find the ratio of corresponding sides in pairs of similar sides and then use that ratio to find the unknown lengths. We have learned conditions of similarity of two polygons. Can we state the same condition for similarity of two triangles? Take a look at the triangles ABC and PQR. Now, superimpose the two triangles. What do you observe? On superimposing, we find that of the two triangles, one is smaller than the other. That is, the two triangles have the same shape but are of different sizes. So, we can state the same condition for similarity of two triangles. That is, corresponding angles are the same. So, angle A is equal to angle P, angle B is equal to angle Q, and angle C is equal to angle R. Corresponding sides are in the same proportion. In two similar triangles ABC and PQR, AB by PQ is equal to BC by QR, which is equal to CA by RP. Thus, we can state that two triangles are said to be similar if the corresponding angles are equal, the corresponding sides are in the same ratio or proportion. Check whether the given two triangles are similar. In triangles ABC and PQR, we see that angle A is equal to angle P, which is equal to 50 degrees. Angle B is equal to angle Q, that is equal to 100 degrees, and angle C is equal to angle R, that is equal to 30 degrees. So, corresponding angles are equal. Now, take the ratio of the measure of the corresponding sides, that is 4 by 2, that is equal to 5 by 2.5. So, PQ by AB is equal to QR by BC, that is, the corresponding sides of the triangle are proportional. So, triangles ABC and PQR are similar. Determine the length of the unknown side of the given similar triangles. Let the unknown length of side be x meters. We know that the similar triangles ABC and PQR, the corresponding sides of the triangle are proportional. So, PQ by AB is equal to QR by BC. Substituting the known values and simplifying, we get 12 by 4 is equal to 9 by 3, that is equal to 15 by x, which is equal to 3. Solving for x, we get x is equal to 5, which is the length of the unknown side. Where else do you observe the application of similarity in real life? In real life, we observe that the concept of similarity is the basis for scale drawing in architecture and engineering, scale models from toy model airplanes. Architects use scale drawing to design houses, hotels, etc. The following floor plan is an example of a simple house design, originally drawn at a scale 1 by 4, where every 1/4 drawing would represent 1 foot in the actual house when it is built.